SCFGLive!
The science of crystals.
Cool! Hey, Katie. Oh, hi.
Hey.
What's going on?
Well, I was meditating to try to understand the power and majesty of crystals.
Wow.
So beautiful, so rare.
Well,
But I just can't think hard enough to make it work. I don't understand them.
well, actually, Katie, crystals aren't that rare.
What?
They're all around us.
What?
Yeah. In fact, salt that you put on your food is a crystal.
What?
And sugar that you put in your coffee or tea is also a crystal.
What?
Yep, they're all around us. In fact, Katie, I think there's a better way that we could learn all about crystals today instead of just meditating on them.
Okay. Can you teach me about it?
Sure. Well, Katie, what do you think we could use to learn more about crystals? Katie, we do this every single time. Come on, it rhymes with science.
Science!
You got it, exactly. So
I'm so wise for thinking of that.
I'm glad you finally did. Katie, what do you say we use science to learn what crystals are, how crystals form, and maybe actually we can even use the power of crystals to make ice cream.
Oh, I knew crystals were powerful. Let's go!
Let's do it.
So what even is a crystal? A crystal is like a cool rock, but what makes it different from other rocks? Well, to answer that, first we're going to need to know what an atom is. Not Adam, my friendly neighbor, spelled A-D-A-M, but atom, A-T-O-M. An atom is the basic building block for everything around us. Everything is made up of tiny atoms. This marker is made up of atoms. Even this rock is made up of atoms. I am made up of atoms, and so are you. In order for atoms to make up these things, they have to be arranged differently and create different patterns. But with crystals, atoms are arranged in a special repeating pattern. Remember how we said that salt is a crystal? Let's take a closer look with our handy dandy magnifying glass. Do you see a shape? This salt is kind of like a cube or a square. Now, we can't see on a microscopic level, we just don't have that technology. But we can imagine on a microscopic level that the atoms are arranged in a cubic or a square shape. They connect with each other to form a square, and they do it over and over and over again until it gets so big that it makes a cubic crystal. Now we're going to grow our very own crystals so that we can see this process before our very eyes. For this experiment, we're going to need
Sugar, baking soda, salt, 6 cups, all labeled with a sticky note, spoons, warm water, pipettes, or you can use cut straws, and black paper.
First, you're going to want to label 2 cups baking soda, 2 cups sugar, and 2 cups salt. We're going to be very careful and take our hot water and measure out 4 ounces. That's about a half a cup. There we go. And we're going to pour it into our cup marked sugar. Next, we're going to take a spoonful of sugar and dissolve it into our water. Wait a second, what's dissolving? Have you ever had a cup of tea and wanted to dissolve some sugar into it? You take that big sugar cube, drop it in the hot water, and suddenly it's gone. It is mixed with the tea. That's dissolving. If you stir the sugar, it will help it dissolve faster. You're gonna keep adding sugar until no more will dissolve in the water. It might be a little while.
you're going to repeat the process with the baking soda and salt.
Now we're going to take 10 drops of each solution in our pipette and put them in their corresponding cups. You're gonna grab the top, make sure that the tip is submerged, and then let go so that fluid fills the pipette or straw. Then we're gonna count the drops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Awesome. Now I'm gonna do the same thing using a different pipette so that there's no cross-contamination or getting the salt in the baking soda or the sugar on the salt. Next, you're going to place the cups on the black piece of paper and put them in a sunny place, maybe a windowsill. What do you think is going to happen? Check back in a few days to see what could have happened to our different solutions.
The process of crystals forming is called crystallization. Crystals often form in nature when liquids cool and start to harden. Certain molecules in the liquid gather together in repeating patterns. In nature, crystals can form when liquid rock, called magma, cools. If it cools slowly, then crystals may form. Many valuable crystals such as diamonds, rubies, and emeralds form this way. Another way crystals form is when water evaporates from a solution. Salt crystals often form as salt water evaporates, like in our experiment. All right, it's been a full day. Let's take a look at our experiment and see what happened. The easiest crystals to see were the salt ones. They look like squares. The sugar crystals were a little harder to see, but we definitely had one there. Lastly, it looks like the baking soda crystals all clumped together in the middle of our cup. Hannah, I'm feeling pretty hungry. Do you think we could use the power of crystals to make something tasty?
I like that idea. Huh. Oh, I know. I think we could use the power of crystals to make ice cream.
Oh, I love ice cream.
Me too. Katie, why don't we watch a clip from one of our old episodes where I make ice cream? It's pretty simple and easy. And then after, we can come back and talk about how crystals helped us to make this ice cream.
Awesome. I will see you in a little bit.
See you soon.
Let's talk about our second experiment. We're gonna focus more on temperature and we're gonna make my favorite treat, ice cream. Now, for this experiment, you're gonna need a few different ingredients. The first thing you're going to need is some sugar. You're going to need 1/4 cup of sugar. I already measured mine out, so I'm actually just gonna go ahead and pour it into my mixing bowl. All right, the next thing you're going to need is milk. Milk is a really important ingredient in ice cream. You're going to need 1/2 cup of milk. There we go, 1/2 cup. And I'm gonna pour that into my sugar. All right, you're also going to need some whipping cream. You're gonna need 1/2 cup of whipping cream. Perfect. All right, I'm gonna pour that in with my milk and my sugar. And now the fun part. You wanna mix everything together until the sugar dissolves. The best thing to use for this is a whisk. Okay, now for some flavor. You're gonna add in 1/4 teaspoon of vanilla. I'm gonna add in a little extra because I really like that vanilla taste. All right, now whisk that together until the vanilla's all dissolved. Perfect. Now is the kind of messy part. You might wanna do this over a sink or ask your parent to help you. You're going to pour your milk mixture into a quart-sized bath. All right, And zip that up extra tightly because you don't want the milk to spill when you're mixing it up. Nice. Now we're gonna place our bag into a bigger bag with 2 cups of ice. Before I do this though, I'm gonna take the temperature of my ice because I'm curious how cold it is. All right, now it might take a little bit of time for that thermometer to drop all the way down because the ice is pretty cold, but it looks like it's about 30 degrees Fahrenheit or about -1 degree Celsius. I'm gonna write that down in my science notebook. Okay, now, unfortunately, this isn't cold enough, so we need to add something to make it even colder, and that is salt. You wanna add in 1 cup of salt to your ice. That's a lot of salt. Now, the bigger the salt crystals, the better. So if you can find rock salt, that's the best. Otherwise, you can use kosher salt. I'm gonna mix this together and take the temperature one more time to see if there's any changes. Whoa, it's dropping down, down, down. Oh my gosh, it's already about 14 degrees Fahrenheit or -10 degrees Celsius. That's a lot colder by just adding salt. We'll talk about why that is in a little bit. Okay, now the fun part. You want to put your milk mixture into your bag of ice. Make sure all of the air is out of the bag and zip it up nice and tight. Now, this bag with salt and ice is actually really, really cold. So you want to use some oven mitts or some winter gloves when you're mixing it up. Next, you might want to grab a buddy for this because you need to mix it for 10 minutes, just like this. All right, now this is gonna take some time, so I already have one that was done earlier that I wanna show you. When you take your bag of milk out of your bag of ice, make sure you rinse it off because it's gonna be covered with salt. Look at this. This is the one I did earlier. Remember, that milk was liquid before, and now it's solid ice cream. So cool. So how did this all happen? Well, while I'm taking a bite of my ice cream, let's talk about it. So what happened was the milk started as a liquid. Now, we talked about in our first episode how things can change phase, meaning they can go from a solid to a liquid or a liquid to a gas. Now, those changes happen when you add heat or cool things down. So in this case, we cooled our liquid down so much that it turned into solid ice cream. That temperature that it hit to turn into solid ice cream is what's called the freezing point. It's really, really cold. Now, once you cool it down enough, it turns into solid ice cream. Mmm, delicious. Let's check in with Dr. Marbles and see how his ice cream turned out. Dr. Marbles?
Kind of mix it.
Hey, Dr. Marbles?
Yeah.
Hello?
What?
What's happening over there? Oh, God.
I'm exhausted. That's what's happening over here.
Why?
Well, I've been mixing this ice cream for like 20 minutes. And I got nada.
Oh, no.
It just looks like milk.
Dr. Marbles, I think you might have forgotten a really important ingredient.
Which one's that?
Did you add salt to your ice cream? Not to your ice cream, but to the ice?
Did we add salt? Did we add salt?
Oh, no.
Oh, man. Hold on. Why would that have made a difference?
Well, salt is actually really important in making the ice even colder. You see, when you add salt to ice, it actually causes a chemical reaction to occur, which lowers that freezing point and melting point of the ice, making it even colder.
I can't believe I forgot it.
That's okay. You could still use just ice, but it would take a really long time, and I'm pretty sure you'd kind of pass out again.
Well, I'm gonna go ahead and add some some salt to my ice now and get going.
Okay.
I want some ice cream.
That sounds good. We'll check in with you in a second, okay?
Okay.
So adding salt's a really important component when you're making ice cream at home. That chemical reaction that occurs between the salt and the ice makes that ice even colder. We saw that when we recorded the temperatures of the bag with ice and the bag with salt. The bag with ice was 30 degrees Fahrenheit, but the bag with ice and salt was 14, which is a lot colder. Pretty cool. Now, I'd encourage you to experiment more at home with ice cream, maybe adding in different flavors or trying it with different milk. Be sure to tag SCFGLive so we can see how your experiment turned out.
Wow, Dr. Marbles sure was funny. He thought that hitting his bottle of milk with a whisk was going to make ice cream.
He sure was creative. All right, Katie, so in that clip, we saw how adding salt to our bag of ice helped to lower the temperature of the ice, allowing us to make ice cream even faster.
Yeah, I never thought that salt would be so helpful when making ice cream. But where do crystals come in, Hannah?
That's a great question, Katie. So it turns out that ice is just the crystallized form of water. In order for ice crystals to form, the water molecules need to slow down and get into nice, orderly patterns. Now, the warmer it is surrounding our bag of ice, the more these water molecules want to move, and the harder it is to get them to slow down and get into that line.
Oh, so it's like when it's a really, really beautiful day out and my friends and I are playing outside at recess, and then the teacher says we have to line up to go back inside, but we're all just so excited to be outside we don't want to stop playing.
That's a great connection, Katie. I know when I'm outside for recess, running around with my friends, and my teacher says, okay, time to line up. I have a really hard time lining up and slowing my body down. I think that the molecules are feeling the same way.
Oh.
So what happens in our bag of ice is that as the ice starts to melt, the salt molecules are now interacting or playing with the water molecules. Now, the salt molecules make it harder, even harder, for those water molecules to line up in a nice, orderly line. This means that our ice cubes are gonna melt even faster, and they're gonna have a harder time turning back into ice. As these ice cubes melt, they start to absorb more and more heat from our milk mixture, allowing our milk mixture, the ice cream, to turn into ice cream even faster.
Oh, so that's the reason why we put salt on our driveways in the winter after it snows, so that the water doesn't melt and then refreeze into ice.
Exactly. I don't want to be slipping on my driveway.
Absolutely.
Always good to use salt in that case. Well, Katie, seems like crystals were really helpful in making our ice cream today.
So can we go eat the ice cream?
I think now we can.
Yeah!
Wow, Hannah, I learned so much today about crystals.
I know. And it's super cool to see that crystals are all around us, not just in the rocks, in the earth.
And you can make them.
It's true. You can also use the power of crystals to make delicious, magical treats, like ice cream.
I knew crystals were magical. I told you.
Katie, I still think there's a lot of science involved, not just magic.
Nope, I'm gonna prove that these crystals that we made are magical. Watch.
Wow! I guess there is some magic involved in crystals after all. Well, thanks everyone for joining us on another episode at SCFG Live. We hope you have fun experimenting at home, and we'll see you next time. Bye!
Science Club for Girls Live. Let's all take one deep dive into the world of science, technology, engineering, and math. Get your safety goggles, 'cause we're making things explode. Science is so fun, so let's take it on the road. Meet a young scientist just like you and learn all about what they do. We'll even learn science that's in the news through one-on-one interviews with SCFG Live and friends. Experimenting never ends. Now let's see what's in store.
This episode of SCFG Live has been brought to you by National Grid, who supports Science Club for Girls' mission in making STEM exciting and accessible to all. Both National Grid and Science Club for Girls support women in STEM and are working towards making STEM more diverse, equitable, and inclusive. Science Club for Girls is a nonprofit organization that fosters excitement, confidence, and literacy in STEM for girls and young women from underrepresented communities with free experiential community-based programs. To help keep our programs free, please consider making a donation today. Learn more and donate at scienceclubforgirls.org.